Assalamualaikum warahmatullahi wabarakatuh to all my students. Okay, for this lesson, we will cover types of commodity plastic, which is polypropylene. Okay, given by this slide is the structure for PP containing CH2 and the special one of PP, it contains a methyl side group. And the PP recycling number is given by number 5. Okay, next slide. Okay, for the lesson outcomes, upon the completion of this chapter, students should be able to discuss on manufacturing process, how the PP is made. Okay, write the chemical structure of PP. Okay, it differs from the PE structure in terms of the presence of methyl side group. Discuss the properties of PP. Okay, what makes PP unique, and correlate the structure and properties of PP. Okay, you need to also differentiate between PP and PE and state and write the various staticity in PP. Okay, because of the presence of the methyl group, PP can be recognized in the three different types of tacticity, which is atactic, isotactic, and syndiotactic. You also need to correlate the tacticity to the properties of PP. Okay, what is the properties that affect the placement of this metal group, and identify the various applications of PP. Okay, in 1954, K. Ziegler and G. Natter found a Ziegler-type catalyst which were capable of producing high molecular weight polymers from propylene and many other olefins. The development of PP was very rapid, with isotactic PP being marketed in 1957, and the material became available at abnormally low prices, which in turn stimulated more growth in usage. And the production growth rates for PP have generally been higher than for the other major tonnage plastics, and in the mid-1980s, PP moved into third place after PE and PVC in the plastic production niche. So basically, the most widely used and produced PP are isotactic PP, the one that is with high crystallinity. Okay, so isotactic PP have a very good crystallinity because of the presence of the methyl side group at the same site. Okay. Okay, now we look at the next slide. Okay, PP are similar chemically to PE but have somewhat better physical strength at a lower density. Okay, so the special unique of PP, it has a very low density. Okay, the density of PP is among the lowest of all plastic material, ranging from 0.9 to 0.915. Okay, so even though it has a very lowest density, it has a good strength in term of strength. Okay, means that walaupun dia ringan, tapi dari segi kekuatan dia sangat bagus. Okay, PP is the only high volume thermoplastic that is processable by all major fabrication methods, such as molding, extrusion, films, and fibers. Okay, the chemical structure for PP, as we can see here, it contains of the methyl side group in each repeating numbers. Okay, for each repeating number, CH2, CH, and CH3, all this methyl will make the PP either in isotactic, atactic, or syndiotactic form. Okay, PP is made entirely by low pressure process by Ziegler, Natter, and metallurgical catalysts. And the properties of PP are strongly dependent on the catalyst composition and its particular size and shape. Okay, metallurgical catalyst is the one that we produce PP by the Ziegler Natter, and to produce a syndiotactic PP. So syntactic PP is the one that we have with the structure of alternate. Okay, this is a new polymer. Okay, which is very hard to produce. Okay, this one is the steps to produce the PP. Okay, from the monomer propylene. Okay, monomer propylene produced by the cracking of petroleum products such as natural gas or light oil. And by low pressure process, catalyst will be introduced into the reactor system, and we use the titanium trichloride TiCl4 or aluminum alkyl, including aluminum triethyl, aluminum tributyl, and also the presence of diluents, which is naphtha. And then we go to flush drum to remove the unreacted monomer, which is purified and recycled. And it will go into the centrifuge to remove the bulk of the solvent together with most of the aesthetic material, which is soluble in the naphtha. And next, we go to catalyst decomposition. Of course, the catalyst must be removed from the system because we use the heterogeneous catalyst system, which is involve the transition metal. We can remove the catalyst from the polymer. And if we go to centrifuge to remove the solutions of residue, and if we go to last step, which is washing and drying. Okay, now we look at the next slide. Okay, this one is the flow that what's happened in the preparation or the polymerization of PP in the reactor. Okay, now we look at the introduction. Molecular weight of PP, okay, can be controlled by use of hydrogen as chain transfer agent, number of catalyst component, polymerization temperature, monomer pressure, and also the catalyst concentration. And PP, having broad molecular weight distribution, is suitable for extrusion process, while PP that have a very narrow molecular weight can be produced by use of metallocene catalyst suitable for injection molding process. Okay, now we look at the structure part and the properties of PP. So why PP has higher melting point than PE? Okay, so PP it has it can do the outstanding part compared to PE because for example in types of the dishwasher safe food containers, okay, it doesn't melt below 160 degrees C. Compared to PE, okay, PE will melt at 100 degrees C, which means that PE dishes will warp in the dishwasher. So for a clear vision, we can see that the application of PP, okay, for example, in widely used food containers because it can retain heat. Okay, why PP has higher melting point than PE? Okay, because the effect of a methyl side group attached to an alternate carbon atom on the chain backbone. Okay, so this metal side group will give the structure of the main structure. Stiffening means that the main structure will not easily rotate because the metal side group will hold um, the main structure to rotate. Okay, dia akan pegang structure tu supaya main structure tu takkan easily rotate. So because of the methyl side group, the properties of strength of PP is higher than PE. Also, an interfere with the symmetry will have increase in melting point. And as a result, the net effect is an increase of 50 degrees C in Tm higher than most regular PE. Okay, so PE, dia punya boiling point dia dalam around 100. Okay, so for PP around 150 to 160. Okay, structure and properties. Why PP is susceptible to degradation compared to PE? Okay, so dia punya disadvantages of PP compared to PE, dia senang untuk degrade under the environment or oxidative cleavage. Okay, oxidative cleavage lah. And why? Because of the tertiary carbon atom allowing for easier hydrogen abstraction, and it provides a site for oxidation. Thus, we make the PP less stable than PE. To the influence of oxygen and thermal and high energy treatment leads to change seasons rather than cross-linking. So dia, okay, if we look at the structure here, dekat sini main structure contains a methyl side group. Okay, so this is we call as a tertiary carbon atom. Okay, dia panggil carbon atom yang ketiga. Okay, so dekat sini carbon atom ni dia senang untuk oxygen ataupun UV light attack this change. Okay, change dekat sini. The change that the methyl side group attached to the main chain. So when the change are attacked by the oxygen or the UV light, this polymer will be turns into some radical site. Okay, dia akan break this here. The bond will break here, and it will break into the carbon with a active site. And the active site, or we call as chain, active chain, okay, will attack the other carbon. Okay, active site tu dia akan attack other carbon atom, okay, ataupun radical. Okay, the radical will attack the other carbon atom and will make the weak of the structure and become easily degrade. Okay, now we look at the other slide. PP versus PE. Okay, PP has lower density and it has the paling lowest density among the other polymer. It also have a superior stiffness and excellent stress cracking resistance, more sensitive to UV degradation. This is the disadvantages of PP. The TG and TM is higher, which also creates higher surface temperature. And for this reason, sterilizable medical devices and dishwasher safe containers are made of PP. Better crack resistant due to mechanical stresses. When subjected to extreme bending, PP does not blush or craze like PE will. Okay, this one is the example of environmental stress caking for PP. Okay, so what is environmental stress cracking? It is a slow crack or growth crack. It is long-term aging process leading to brittle failure, accelerated by scratch and stones. So it is unexpected brittle failure of TPE accounts for 15 to 30% of all plastic components failures in service, caused by exposure to liquid chemicals, occur mostly in amorphous brittle polymer like PS and PC. ESC and polymer degradation are not the same thing. Polymer degradation involves breaking polymer bond, whereas ESC does not. ESC breaks the secondary linkage between polymer instead.